Okay, I'm going to give a quick explanation. I think it's number 6 on the HCl-DCl problem. Let me double check that. This is where you are including the centrifugal distortion on, not number 6, number 9. So grasping the anharmonic model theory. So determine delta S. So this is S, but now we're going to do delta S. And so you know that G will equal, including anharmonic information, you've got equation 11C.8, which tells you that G is equal to V plus 1/2 mu tilde plus, I'm sorry, minus, because this is an anharmonic model, V plus 1/2 squared xe nu tilde, where this is the anharmonicity constant. Now this is an expansion. This is a power series expansion that you could continue going down and adding more terms. But what's happening now is that we are looking at just the V value. Okay, and this is one of the terms that you're going to be solving for. For the F, so this is G, so F of J, and so now we flip back to page. So now this is looking at the rotational contribution, and so we're looking at the centrifugal distortion. I'm on page 434, and we've got BJ plus 1 minus DJ tilde J squared J plus 1 squared. Now, so this then is the centrifugal distortion constant, as well as B here, B tilde includes the anharmonicity or the vibrational rotational coupling constant. Okay, now that's not included in Atkins. He says that it's there. He says that you could use it. Well, we're going to use it because, damn it, we're going to do PChem fully. We're going to really embrace this HCl-DCl problem. So on page 3 of the HCl-DCl assignment, you'll find that I have noted that B here is really equal to B equilibrium. So this is the equilibrium rotational constant, which means it's the most likely or most probable equilibrium constant associated with the most probable equilibrium of the separation of the two nuclei, minus alpha E, where this is the vibrational rotational coupling constant. Big number, lots of coupling. Little number, not so much coupling. B plus 1/2. Okay, so what I want you to do for number 9, you're going to assume that this, not assume, you're just going to do it, is this B term. So if you were to set this up, you're going to say, okay, delta S, which is equal to S of B plus 1, J plus 1 minus S tilde of B J. Okay, now what you can do is to link these together. You can say these are my double primes, because V double prime and then would be the ground state V double prime, and then the first excited V would be V prime. And so you're looking at that transition where V prime equals V double prime plus 1. Okay, and so now what you're going to do, likewise with J double prime and J double prime plus 1. Now what you're going to do is you're going to input each of these into everywhere you see a V and a J. Okay, so your expression should be delta S equals this first one, V double prime plus 1 plus 1/2 nu tilde, or V tilde, minus B double prime plus 1 plus 1/2 squared xe V tilde plus, now we're going to do this. I recommend leaving this as, well, no, you can't because you've got the B one here. Okay, So then you're going to do the same thing for this whole term here, and then you're going to subtract, there's the delta here, this whole term, okay? I recommend doing this in two steps. Do it just for delta G and do it just for delta F, and then add them together, okay? Because you could say the same thing where this is the same as, so you've got G V double prime plus 1 minus G V double prime plus F J double prime plus 1 minus F J double prime. So write this out with each one and then simplify it and add it together. What you should get, and you need to show this, is, and I'm going to give it to you because it helps to recognize what you're going to get. So I'm just going to give you the delta F part. So you're going to get 2b tilde j plus 1, should be j double prime, minus 4dj tilde j double prime plus 1 cubed. It simplifies to that. Okay, and this is where your the cube term comes in. Now, you most likely have this as j cubed plus 3j squared plus 3j plus 1. It's good to recognize that this is j plus 1 cubed. So if you keep j plus 1, what will happen is the algebra will take you far. But if you can keep things in terms of j plus 1, it would simplify much easier. And then for your increase in rotational state, you'll be looking at delta j plus 1, or sorry, you'll be looking at j double prime plus 1, and then that will become your x value. Whereas with the delta s for j double prime minus 1, which is the decrease in the energy state, or the p branch, you're going to have all of this, but with a negative sign for j double prime. Cool? Again, what you are doing is you are creating the theory behind the cubic function you're going to fit your data to. We got to figure out what those coefficients mean. And this is how we do it. Go team. Okay. So that's going to be the delta F. And then what I would suggest then is then input this B E minus alpha E V plus 1/2. Okay. Cool. And then your delta G would have an additional component to it. All right. Hope that helps. Email questions.